J'entends rien. Okay. Hi, everyone. I'm getting ready to answer your questions. I think I will see them on the sidebar here. Yeah. Oh, Rahul. Yeah. Oh, Stefania. Yeah. Thank you. Oh, tactile sensors. Yeah. Yeah. Hi, Zanet. Takes time for typing all these questions. You, yeah, actually, since it's the link is established, are you? Ooh. Hi, Ildar. Okay, I'll try to. There's many. There's a very large flux of questions now, but I'll take that one. There is a question from Shihan Lu, who is asking whether people can allocate perception between auditory and haptic feedback when interacting with a texture. So that's interesting. I think, yeah, the merging of senses can depend actually a lot on attention. So you can actually direct your perception towards a particular aspect of a stimulus, and it is definitely the case that if you are experiencing a texture, like you would be rubbing your finger on, say, like a surface of cork, and it makes a certain noise, and then you feel the texture of the cork, and then the two actually gives you the experience of cork, and you could definitely modify. You can really direct your attention on one aspect. You normally don't, because that's not what you need to behave. Uh, you actually take advantage of the two inputs to simplify your life essentially, but definitely attentional processes can modify uh, what you experience. There is a question of Catherine Minor. When does the perception of a stimulus from haptic feedback override that of visual feedback? Yes, so yeah, lots of examples of that. I mean, there's famous paper by Mark Ernst on the different weights. Uh, so that's really the simple answer. If you have a visual input that's less reliable than the tactile input, then tactile input takes over. There are other cases when that's the case, in fact, but that's the most obvious. Ooh, it's moving fast here. Yeah, there is a question about designing haptic, doing haptic perception studies with a 3D printer. Yes, definitely is a good idea. because you with a 3D printer you can create objects fast. There is one limitation though, is when you 3D print um, an object, you have no very little control on the surface. So it can be rough or it can be smooth, and so that's can be a problem. But you can make objects very quickly by 3D printing, and then you can varnish. You can actually uh, um, uh, finish them with a coating and so on. So it's really a good idea. Mirth, hi, hi, Mirth. Mention that cost and complicatedness play a role in sometimes not being able. Yes, yeah, that's really a good point. Yeah, I mean, in my short experience of having attempted 5 times now to turn, um, uh, if you want, lab prototypes into something that is industrializable, really there is no doubt that there is a break point. I mean, many haptic, quote unquote, haptic inventions are very hard to industrialize because it's a simple thing. It's because they are usually mechanical objects, and it takes a lot of work, a lot of R&D to turn a mechanical object, especially with electric motors and so on and so on, into something that people would like to buy for low cost. Uh, no, it took a very long time, for example, for cars to be mass manufactured. Everything mechanical has this problem, haptic devices is no exception. And so this is why at the company here we really focus on maximum simplicity in the designs and maximum effect in from the perception viewpoint. There is a question by Chao Chao Cheng. What kind of somatosensory system is used to have tactile illusion? Well, the somatosensory system is nothing, is only one. It's all the organs that you have to be able to experience tactile sensation, like, and it's a scientific term for basically the sense of touch. That's all. There is no difference. You have the visual system, the auditory system, and then you have the somatosensory system. Yeah, there's an interesting question by Jack 9653. Can you explain the importance of skin deformation in proprioception? Yeah, actually, the person you should ask is Professor Benoni Edin from UMEA on this point. He's really worked all his life. I mean, a good part of his career on the spindles in the muscles, but also on the fact that the skin uh, provides proprioceptive information, and it's really an interesting piece of knowledge. Benoni actually told me that he discovered this because he was working with patients who uh, uh, actually had large burns in their body from accidents, and they had trouble moving, and they actually realized that actually the lack of inputs from the skin prevented them from having a good knowledge of where the body was in space. So that's really interesting. And later he made studies on the knee and phalanges, and and so it's very interesting that actually proprioception depends on the skin in a significant way, and apparently mostly on the torso and the extremities, not so much the shoulder. But So that's a rough picture. But you should ask Benedict for more detail. Yeah, there is a question about by Kazukuski on why always focusing on hand and fingers and what not doing haptics with the other parts of the body. Of course, it's a good idea, but the hands are more dexterous. So that's the one you normally, it's the part of the body used to manipulate. So that's why you do haptics with the hand. But actually, there's been very good projects on doing haptics with the feet. It's very, very good place. So you could have a haptic shoes. We have a couple of papers on that. Obviously, quite a few people made papers on haptic shoes. Um, you can also use skin anywhere on the body for what it's good at, you know. So that's really the answer. A question by Ahmed Farouk. Uh, Devices that the user doesn't have direct contact with. Okay, that's complicated. I mean, there's possibility to transmit mechanical energy through air. So that's one option. Uh, but you can also there's been a few things done through gels actually. But of course, the sensation comes out because your skin is stimulated, so you really have to have a medium for doing that. Question by Godaba Harish. Can you share any lessons that robotics researcher can learn from haptic perception studies? Oh, many. Really many. Actually, there is a very uh, um, a point. Actually, you know, the traditional view in robotics is to uh, think of robot architectures as loops. You know, so you have like sensing, decision, action, and that's really the traditional way to look at it, and the way practically all robotic system I can see today are organized around. It turns out and of course you have other architectures like layered architectures with different loops and behavioral and so on. But my impression, I could be wrong, but my impression is that in robotics, the field has not appreciated at all the concept that perception and action um, is not a loop. Actually, it's at least in animals, except simplest animals, but in all big and fast-moving animals, perception is really a process by the brain that is actually predicting what should be an input, and so that's something that has not been that's been studied a lot in perception. I'll give you a very classic example, which is there are two actually that are so telling. Uh, when you are looking around, you see a room and you see a screen, you see a computer, you see a person, you know, in its entirety. But as you know, your eye has a foveal structure, and you actually see through a few degrees of angular um, aperture, sharply, all the rest very, very blurry. But when you look around, everything is perfectly sharp. And so that's essentially a manifestation of what your visual system does. It basically predicts what should be seen. It doesn't see it. And so you have uh, other examples, like for example, the famous attention illusion, like when you have a distraction that you fail to see changes, so you have changed blindness and so on and so on. Lots of examples. There is in touch, in audition, and so on. And all this never been, to my knowledge, really appreciated in robotics, and that's really uh, a very good uh, path for doing more biologically relevant robotics. There is a question by another question by Raoul Rai. Doing psychological experiments on subject becomes difficult when the duration is high. That's for sure. So that's all the art of doing good studies, is to obtain a result within a reasonable amount of time, and 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 uh, uh, and that's really why it's so hard to do. I mean, good studies. It's because you are limited by the time. It's that simple. And if you test people and either in natural settings or in laboratory settings, you're always limited by the time invested into this. So that's really a good point, and that's what good studies are. Is when you can get a result within these constraints. Uh, there's a question by Jara. Yeah, so dynamic mechanoreceptors are very sensitive for sure. uh, and how strong is this compared to static? I don't think it's a good question, but I don't think it can be answered. I think they're both important, uh, uh, and um, I'll answer it another way. Actually, what really seems to be the case is all the mechanoreceptors you have in the skin and uh, actually they converge to the same cell. So there is actually no segregation of pathways, if you want. They are really all important in such, and that has many consequences. Actually, I have a friend who made a very astute observation about this. You know, for example, if you cut your finger and you have a scar, and the scar, and then it heals, and I have one actually. Scar is pretty big. It's completely scar tissue, so there is no mechanoreceptors in them, but it doesn't change at all my. I don't have a blind spot, if you want, in the scar. And the reason for that, it's what I explained earlier. It's all the mechanoreceptors in the large regions converge to the same cells. So if you remove a few, it doesn't really matter actually, and that's the answer. They're all important, and they but they are you cannot wait. You know, there is no weight or separate channels for each other. Then another question. Let's see. Uh, okay, one more question. Free versus constrained exploration, is the surface property influencing the movement? It's cells so that movement is ah yeah, that's also been a long yeah. How is it possible that when you feel a surface or say a piece of fabric, then you have the same sensation if you move your hand or someone else moves the surface? And so that's kind of a mystery, and it's kind of interesting. Uh, uh, there are several answers to that. The simpler is that actually for certain aspect of the properties of object, as long as there is movement, whether it's self-generated or whether it's externally generated, makes no difference. And texture is what is a case actually for that. And but yeah, it's not a very good answer, but that's the beginning of one. A question from Gaia Risso. Could you explain how information about body size and shapes could affect haptic perception and vice versa? Yeah, that's really good. Actually, uh, um, uh, for me to be able to feel the table or my phone here, actually to make sense of the mechanical information I collect when I grab something or I interact with it, requires that I have a knowledge of my own body. So that's obvious if you think of it in mechanical terms. You have to have the if you want the perceiving object needs to have a model of its own transducer, if you want. And that's true actually. So, but you can make really fun experiments. For example, you can attach uh, uh, sticks to your nails, so you become like a different person if you want, and then you explore around, and then everything feels differently. But what is remarkable is that within minutes, then you incorporate these new appendages that you have added to your body, and that's something I didn't touch upon, but it's actually very prominent in touch. Is that it's a sense that has a tremendous learning capacity. So if you modify the transducers, it will very quickly understand how to use them, uh, uh, and then redevelop the models that are needed to interpret the data. And it's very quick. It can be happening in matters of seconds. So that's actually a very good news also for designers of haptic interfaces. There's a question by Ravali Greshti about the Pacinian corpuscles. Well, they are, of course, really important. And I don't think they have any 1D, 3D, or any other D properties. They basically respond perturbation in the tissues in which they are embedded, and they respond by a train of spikes, which is particularly characteristics in the sense that the train spikes phase lock with the mechanical stimulation, and that's something I find fascinating, and probably will continue study in the future. Tool embodiment. Yeah, definitely. So there's a question by Yongbu Shim on the study on tool embodiment. Actually, we didn't check. I mean, yeah, it's definitely if the visual appearance conflicts completely with the mechanical experience, you probably have an effect. It's a really good question. Like actually, we've a ongoing study on this, which actually to replace completely the a tool by a if you want the virtual tool. So it's actually not a physical object, but something a software object, if you want. And then so that will have actually a great method for studying what you are asking here. So we could actually completely separate the mechanics from the optics or visual. Yeah, so I'm Guillaume Chauvet. And that will be the last question, actually, because I'm instructed that we should stop this session. But you can keep sending me questions. I will answer them as soon as I can. And I will answer the last question at the bottom of the sidebar here. Simple haptic feedback that clicks. What would be a good metrics to qualify the feedback? My hunch here is that it really depends on context, but there's two aspects. There is one which is pleasantness. So there is no doubt. Actually, there's no difference with real clicks. Like people prefer a certain type of keyboards because they are softer or they are sharper or they a nice detent and so on. So and all these things can be, of course, reproduced artificially, and that's really a question of liking. There is no it's not really. I mean, the metric would be actually pleasantness. So that's really what we can do. And actually, it's a great advantage to be able to have virtual buttons because you can really make them the way you want. Yeah. So on this one, I'll sign off, and then I will continue looking at the questions offline. Thank you very much. Okay. Bye bye. Yeah.